Determine an equation of the inverse of that. Sketch it and its inverse, and then it asks again if the inverse is a function. So, one thing to be careful in this, in the language. When it just says inverse, it can be a function or not. Whenever it says inverse function, it has to be a function. Or whenever it uses this notation, f with a -1 of x, that means inverse function. So this question just says determine an inverse of the equation. So algebraically, we wrote this down before, when we're figuring out an equation for the inverse, first thing we do is switch x and y in the equation. So all we're doing is switching x and y, and then we need to solve for y. So we want to get y by itself. What could you do? You could subtract 4 on both sides, multiply by a -1 to get rid of that negative sign, and then once you get y squared by itself, the opposite of squaring, square rooting, but when we square root, we have to remember the plus or minus. Oh, this is a good question. I like this question. So, it's a square root graph. It's actually two square root graphs, because the plus or minus, what that means is we have one equation with the plus, square root of -x plus 4, and one equation with the minus, which is negative square root of -x plus 4. What kind of transformations are there in the top one? Okay. Okay, so we got a flip and we've got a translation, and here we've got two flips and a translation. Okay? And which way is the translation? To left. Why is it to the left? Because you see the plus sign. And we all forgot about the special note. Oh. This is the hardest one to see, because the special note says whenever there was a horizontal stretch, compression, or reflection, and a horizontal translation, you have to write it in factored form. So both of these would need to be rewritten with that negative factored out, and it's actually 4 to the right. Oh no. Which makes that last equation really negative, right? Negative, negative, and negative. So it's actually 4 to the right. So part B, sketch the graphs of both. How do we graph -x squared plus 4? You would move it. You would, first of all, -x squared. Here, start with your parabola. The negative would flip it down, and then the plus 4 would move it up 4. So we would have our vertex at 0, 4, and our parabola going down. Is that what the original equation was? Good. -x squared plus 4. We're graphing the original, which is -x squared plus 4, and we're going to graph the inverse. Two ways of graphing the inverse. Either we can take the equations that we found, or we can just switch the x and the y of a bunch of points on our original one and flip it over this line. Y equals x. So what's going to happen to 0, 4? It's going to go to 4, 0. what's going to happen to 0, 2? No, 2, 0. Going to go to 0, 2. And this one at negative 2, 0. And if we switch the x and the y, that is the graph that we're going to get. Okay? If you wanted to graph the green one using the equations that you found, what is our first equation? The negative flips it. We have our square root graph, right? Here's our regular square root graph. Going from left to right, we have a negative that would flip it over the y-axis and move it 4 to the right. Can you see that that would draw this top part? The second one, you would flip it down, then flip it over the x-axis, then move it 4 to the right, and that would draw the bottom half. So both of those square root graphs are drawn, and putting two square root graphs together will make a sideways parabola. Is the inverse a function? No. Doesn't pass the vertical line test. What is this? Oh, at the bottom of page 239, they ask, when is the inverse of a function also a function? How could we tell by just looking at our first function whether or not the first function, the inverse is going to be a function or not? Okay, so for example, we just did a parabola. The inverse is not a function. There you go. Jack's got it. The test to see if the original one is going to have a function that's an inverse is the horizontal line test. Because what happens to a horizontal line when you flip it? It turns into a vertical line. And so if your original graph passes the horizontal line test, your image after the inverse is going to pass the vertical line test. So this one doesn't pass the horizontal line test, so its image is not going to be, its inverse image is not going to be a function. But if you took something like an x cubed graph like this, does it pass a horizontal line test? Yes, it does. So its inverse is going to be a function. Oh, the questions for example 2 are 5 and 6.